So going back to our project here, so we've seen now that we've basically added these weights and groups. We've used this. Excuse me, I go back to up here a little bit. We've added these float vectors, which are basically just going to be a number of inputs that we're going to send to R. We've done up this GL command, which we can reference if we want or look at what it means. If we go to the R libraries and look up GL, this generate factors by specifying the patterns of their levels. So we're basically applying different kinds of associations of inputs, given their factors, and then applying them to specific weights and groups. We're going to then apply to a linear model. So in all these cases that you can see here from lines 41, for instance, in where it's applying the weight and group. First of all, the weight and group are associated together using a text input. So you can see that here we're using an R kind of simple command, which you can basically print using different kinds of print statements or different kind of text statements that can allow them to referencing using R syntax. But also you have R commands directly as methods applied within the R libraries in RPY2. So the LM is linear model, for instance. So you can give it the R syntax of how you send an input to a linear model in R, but the actual command is still using the R method as created in a method statement within RPY2 that is within Python. And then it'll basically apply different methods such as analysis of variance, again another R method, which can also be applied within the Python reference. So in this case, there's a method, direct Python method that allows us to access the R method. Same thing for the linear model down over here, the weight and group -1, and even the matrix and other kinds of things like we're doing principal components and even printing a file. So if we run this, what we should do is get basically a linear model that looks at weights and groups within this linear model, looks at a kind of analysis of variance as well as a principal component analysis of these inputs and produces values related to that, and also printing out a kind of graph that shows the eigenvalues from the principal component analysis, which you can see is done over down here, the plot statement. So again, the specifics of the commands are not that important. What it's more showing you how you associate R within Python. You may need to run this, you may actually have to create a variable in your environment. So if you go to the command where you go into the Python, this time we're using regular Python to run this. So instead of using Jython, we're using a Python run. Here it's under simple.py. So most of it's going to look very familiar to you, nothing really incorporated. However, in some environments, you may need to create what's called an R home environment. So you'd go under environment, you create a name, R_home, and then you reference the pathway in which R is located, maybe under the user folder or whatever folder you have it under. I don't think I need to do it here because I think it's automatically dynamically referenced, or it has been referenced within my Linux environment, but I'm going to go ahead and run it just to show you the actual output. And there you should get, yes, the actual set of outputs using different R commands, whether it's the GL command, the linear model command, the analysis of variance command. All these things, again, were created using R methods that were referenced or that have specific equivalent references within Python. But again, the inputs have to reflect what they are in R.